All right, good afternoon. We are going to learn about differential equations. That was a little arrangement I put together on the guitar for the Mission Impossible theme song. Mission Impossible is a television show back in my younger days, back in the early 70s, if I remember right. So hope you enjoyed that, just for something a little bit different. What I'm going to look at here, and this is a real short section, I don't have too much to go through here, is what differential equations are. And the thing is, now that we are have learned about integrals and derivatives, we can kind of put this together into a topic known as a differential equation. And there's classes devoted to differential equations for engineers and scientists and so forth. For business persons, you get into differential equations in economics and other topics, certainly. So to begin with, what I want to look at is just kind of show you what we mean by a differential equation. And the idea of a differential equation is you have an equation, you got, of course, got an equal sign, but you have a derivative in there somewhere. So a derivative, of course, can be written in all kinds of different ways. dy over dx, we've seen that. Y prime, y double prime being a second derivative, y triple prime a third derivative, and so forth like that. So if you have an equation that has a derivative in it, then it's a differential equation. So that would be a differential equation. That would as well. And the other thing is just kind of a little terminology on this. We name these a certain way. And what will happen on this is this one right here has a first derivative in it. So we would call that a first order differential equation. This one has a second derivative. The highest derivative it has in it is a second derivative, so that's a second order. And then this is a first order like that. So you just want to know the terminology behind that. We aren't going to solve anything other than very, very simple differential equations in this class, though. Okay, so to begin with, here's just a couple things I took out of your book. What is the order? So this is a differential equation. Its order would be 2. That's the highest derivative, so we would say that is a second order differential equation. This one would be a first order differential equation, since it's got a first derivative in it. And this one has the highest, has a first, a second, and a third, so this would be a third order differential equation. And the last one here, the highest order, the derivative is right here, so that would be a second order differential equation. Okay, any questions about that? Okay, that's just terminology and that you want to know. Next thing I want to talk about is a solution to a differential equation. So one thing that's a little bit different, when you solve an equation, you're used to finding a numeric value. When you solve a differential equation, you're generally going to get a function. So its answer is a function. So here's a differential equation. Okay, this right here is your differential equation. It's a first order differential equation because you have your first derivative there. We're going to see if this function is a solution to this. Okay, so what we would do is we would do these things. First of all, we have the equation dy over dx. It's saying the first derivative of this function is equal to y over x. Okay, well, let's see if this is right. First of all, the derivative of 5x, what is that? What's the derivative of 5x? Yeah, that's 5. What is y? Well, y is 5x. Okay, and then I'm going to just leave the x there. So what I did was I did the derivative and got 5, and then y was just 5x. So I plugged that in. Now let's see, is that a solution? Is that right? Yeah, that cancels out. So that would be, yes, that is a solution to that differential equation. Okay, so that's how that works. Okay, the next one's about the same way. Why don't you all go ahead and do that next one, if you would, yourself, and see what you come up. Okay, everybody got that? Okay, well, let's take a look and see what you did here. So what we have is we have the differential equation dy over dx is equal to y over x plus 1. So what I'm going to do is I'm going to do this. First of all, I'm just going to plug in y equals 8x plus 8 there. So that's going to go right in there. I'm going to leave the x plus 1 alone, though. Okay, the derivative of this function is the derivative of 8x plus 8 is what? That's 8, okay? So let's plug that in and see what we get. Well, what we'd have is we'd have 8 is equal to 8x plus 8 over x plus 1. So we got to see if that's right. Well, what can you do with 8x plus 8? Yeah, you can factor an 8 out. Good. So you have 8 times x plus 1. X plus 1 stays the same. Then what happens? Yeah, then you got a cancellation. So it's equal to 8. So that would be a solution of that differential equation. All right? Okay, good. So what we're going to do is we're just going to solve some real simple basic differential equations in this class, really, okay? We're going to look at some pretty straightforward things, right? So to begin with this, we're going to find the general solution of this differential equation. This is a first order differential equation. So we have y prime is equal to 21x the second like that. Now what we're going to do is the opposite of a derivative is the integral. So we're going to find the antiderivative by doing an integral. So we're going to do the integral of y prime. Okay, now I'm just going to write that as y prime. And then on this, we're going to do the integral of 21x to the second. All right. So, first of all, what would happen on this is the antiderivative of y prime is just y. So you would end up getting y. And then on this is an antiderivative. Remember what we learned is you can take the constant out of the integral. And then we have the power rule for this integral. You're just doing an antiderivative here. So that would be, you want to add 1 to that exponent. So that would be x to the third over 3. Then you got the plus c. Okay, what we'd have there is we would have 21 over 3 is 7. So the function that we would get is y is equal to 7x to the third plus c. Okay, and you're going to have that plus c there because you actually have a family of antiderivatives that are solutions of that equation. Okay, next thing I'm going to do is just show you that it's really actually very easy to check. We have y prime equals 21x squared. So all we have to do is just do the derivative of our answer. The derivative of this answer is 21x the second. Okay, the derivative of c is 0, so that works out. Okay, so it's real easy to check your answer on these types of differential equations that we're going to do. Okay. All right, next one, what we're going to do is solve this first order differential equation. So we have y prime is equal to 2e to the 3x. Okay, going to take the same approach. We're going to do the integral of both sides of this equation. Okay, my email is out of date. Okay, let's see. So this would be y. Now we have a formula for this. I'm going to write this formula at the side here. If you have the integral of e to the kx, this is a really important formula to know. And actually in economics, E really shows up a lot, you know, in different applications, compound interest and stuff like that. So it's kind of important to know this. The antiderivative is 1 over k e to the kx. Whoops, don't need a plus sign there, just need a multiplication there. So that is 1 over k e to the kx. All right? Okay, so when we do this, I'm going to bring out the 2, and then we're just going to do the integral of e to the 3x dx. I need that dx there. Okay, so that's y equals 2, and then by the formula, we'd say 1 over 3 e to the 3x, and then don't forget your plus c. Okay, we can multiply these fractions. 2 over 1 times a third is 2/3. We'd have e to the 3x plus c, so that would be the solution to that differential equation. Okay, let's go over the side and let's check these because they're real easy to do for the most part. So what we're going to do is we're going to take the first derivative of our answer. So if we take the derivative, we would have the, for y prime, you would end up getting 2/3. Now remember, you got a chain rule here. So when you do the derivative of e to the 3x, it's e to the 3x times the derivative of the exponent, which is 3, derivative of c is 0. That crosses out. So we're left with y prime is equal to 2e to the 3x. That's what the problem was, see. Okay? All right, everybody okay? Okay, so see what you're doing is you're doing antiderivatives. You're doing indefinite integrals when you do that. Okay? All right, so the next thing I'm going to do is what we call an initial condition problem. And I pause this for a second. Okay, so this is an initial condition problem. It has an extra piece to it. Here's your differential equation. That's a differential equation. That's a first order differential equation. This thing right here is an initial condition. So it really what it does is it allows you to find the value of c when you solve your differential equation. Okay, what you do is you kind of get a family of functions that are off by a different constant c when you get a solution to the differential equations we've been doing. But when we have an initial condition, we can pinpoint it down to one specific solution then. Okay, so what we'll do to start with this then is we have y prime is equal to 4x plus 7. Okay, I'm going to integrate both sides. So I'm going to do the integral of both sides. And what's the integral of y prime? That's y. Okay. And let's do the integral of this now. So remember what we can do on this is antiderivative. Write down the constant. Do the power rule here. So add 1 to the exponent. And then divide by that. So that's x squared over 2. And then the antiderivative of 7 is 7x. You know, when you get good at doing antiderivatives, always in your head just sort of check them. The derivative of 7x is 7. The derivative of x squared over 2 is going to give you 2x. Okay? And then, so if you worked this out right here and did the derivative of this, you would get back to 4x. Okay, so what's going to happen is 4 over 2 is 2. And that's going to be y equals 2x squared plus 7x. Okay, so that is the function. That's a solution of that differential equation. I forgot one thing. What did I forget? Yes, I forgot the plus c. Okay, so that is your general solution. Okay, so that's step 1, is you just kind of find the general solution. And step 2, what we're going to do now is you're going to use this boundary condition, initial condition. So we have y0 equals negative 12. Now this is an x value. This is a y value. So what you do is you get the point 0, negative 12 as a point on this function. Okay, so what we do is we just simply plug this in. Whoops. So I'm going to do this. So what I'll do is I'll take the solution y equals 2x squared plus 7x plus c. Then I'm going to plug in the negative 12 there. Then I'm going to plug in the 0 everywhere I see x. Okay, so that's negative 12 is equal to 2 times 0 squared plus 7 times 0 plus c. So that's negative 12. See, all this stuff here just goes to 0, so you get c. So now that we have c, you put this together. So the answer is going to be this. Okay, you take this differential equation solution, y equals 2x squared plus 7x, and then you tack on the c. So that's minus 12. So that would be the solution of that differential equation. Okay, you guys follow that? All right, okay. Mostly antiderivatives, like I said, and integrals. Okay, all right. Now, I'll move on to the next thing here. Do a couple of more of these initial condition problems. And what we want to do with this on number 6 is we have first order differential equation, y prime equals 4x e to the 2x. And then we have the initial condition. Okay, now that initial condition, remember what that's doing is it's just giving you a point, 0, 20. Okay, that's the y value. That's the x value. All right, so what I'm going to do is I'm going to do the integral of both sides. And we got to do something a little different on this one now. So this one I'm going to do the integral 4x e to the 2x like this. Okay, now what we're going to do on this is we're going to do a u substitution on here, or because we have this 4x here, so we have to do a substitution on this. Okay, so what we're going to do is we're going to let u be equal to 2 to the x, or 2x. Okay, then I'm going to take the derivative. So I got du is equal to 2 times dx like this. Now this can be a little tricky, so pay attention to what I'm doing here. Okay, so what I need to do now is see this thing that we have here. Hold on just a second. I got to check on something real quick. Yeah, I was kind of looking at this and I realized that I typed this wrong. So this would be an integral that we wouldn't know how to do in this class. So I'm going to show you what my mistake was. And the mistake was right here. That's what I thought. I typed that wrong. So sorry about that. So it should be y prime is equal to 4x e to the 2x squared. Okay, so we're kind of at a stage where we're trying to do antiderivatives mostly in our head. Okay, so what'll happen on this is if I was to go through and do the integral of both sides, I needed to design a problem where you could reason out the antiderivative in your head. So I want you to think about what would happen on this. Okay, if you did the derivative of e to the 2x squared, what would you get? Okay, how do you do a derivative of an exponential, e to a power? Okay, it's always two phases. Itself times the derivative of the exponent. So the derivative of that exponent is 4x. So notice that matches that perfectly, doesn't it? Okay, so this means that what you would get is you would get the antiderivative of y prime is y. The antiderivative of this is just e to the 2x squared plus c. Okay, in this section, the antiderivatives are things that you're either going to do with a basic rule we've learned, or it's going to be something you're going to have to reason out in your head. Okay, so now what we do is we take this initial condition. Okay, so remember, x is 0, so everywhere you see an x, you're going to put a 0 in there. Y is 20, so you're going to put a 20 there. So we have 20 equals e to the 2 times 0 squared plus c. So that's 20 equals e to the 0 plus c. So that's going to be 20 equals 1 plus c. So that would be, solve that equation, you'd get c is equal to 19. Okay, so the answer to this problem is going to be, okay, let's take here's our general solution. Okay, so we'll get y equals e to the 2x squared plus 19. All right, that's the answer right there. Okay, so let's see on this next. I'm going to see if you guys can figure out the next one when you do the antiderivative. So I'm going to pause this and give you a few minutes to see if you can reason through this one. Okay, so let's take a look, see what we got here. So what you're going to do is you're going to do the integral, finding the antiderivative of both sides of this equation. Okay, then again you have this condition. That just means x is 0, y is 3. So that just means you have a point 0, 3. Okay, so the antiderivative of dy over dx is what? It's y, because the derivative of y is dy over dx, just different notation than y prime. What'd you get here? Okay, some of you had a little trouble with that one. Okay, this one is ln of 2 plus x plus c. Okay, now just kind of at the side here. Now, if you do the derivative of an ln, what do? You do 1 over that, like that. And then what you do is you do the derivative of what's inside, which would just be 1. Okay, so that's what that is then. So this is your general solution. So you got your general solution. Step 2 is just plug in. Okay, you have x is 0. That goes there. You have y is 3. That goes there. Then we have ln of 2 plus 0 plus c. So that's 3 equals ln of 2 plus c. And then you could solve for c. So if you solve for c here, you would just move this to this side of the equation to get 3 minus ln2 is equal to c. Okay, that's it. You don't want to get a decimal or anything, just leave it like that. So then you take that general solution. See, here's the general solution. So you take that, y equals ln 2 plus x. Now tack on the c, which is 3 minus ln2, and then this would give you the solution of that differential equation. All right. I mean, you could check this thing too. I mean, if you do the derivative of this, say, you know, I'm going to go ahead and add this one extra step on this. If you checked, see, if you do the derivative of all of this stuff right here, ln 2 plus x plus 3 minus ln2, you get the derivative of that ln is 1 over 2 plus x, and then the derivative of this is just constants. Okay, so you get back to where you started, see? Okay. And then that point is just satisfies the checks in that function too. So if you plugged in, like if you plugged 0 in there and plugged in 3 there, it would all check. Okay, so we'll wrap up the section with just a couple of applications. So this is the same thing we've been doing. It's just kind of attaching it to some scenario. Okay, so this problem number 8, what it says if the marginal price, remember a marginal price is a rate of change, so that's the derivative of the price. It's X units demand per week is proportional to the price P, and if at $80 there is no weekly demand, see that gives you a initial condition. Then it says, and if at $50.18 there's a weekly demand of 8 units, we're going to find the price demand equation by this. All right, so we're going to work on this application. It's an application of a differential equation. Okay, so first of all, with this problem, there's a one thing that we haven't talked about yet. It says that this marginal price is proportional to the price. So what that's saying is the equation would be dp over dx equals x times p. When you're proportional, it just means you have a product like that. So that's the differential equation that we're going to solve. Well, this is what we call a linear, you don't have to know this terminology, it's a linear first order differential equation. Okay, and its solution, this is a little different on this one. Okay, you don't just integrate both sides. Okay, what you do is the solution is y is equal to c e to the kt. All right, so that's the solution. So that's what we're going to work with. All right, so what we have is got this differential equation. This is the solution. Okay, and that's just a given. That's the formula for the solution of this first order differential equation. So you got to know that. I can't really show you where that comes from. I'm just going to give that to you. All right, so now what we're going to do is, that's kind of the first thing, is you got to know that. Then we're going to take this initial condition, and again, this is what t is, and that's what y is. So we're going to plug that in. So we're going to replace y with 80. We're going to leave the c alone, and then we're going to replace the t with 0. And then this will allow us to find c. Okay, that's what we use this for. All right, so we'll have 80 is equal to c e to the 0. Anything to the 0 is 1, so we get 80 is equal to c. All right, so we got that. Now we just put this together. So if we take this general solution, we get y equals 80 e to the kt. Now there's a reason why they gave you another point, is because now we can find k. So we're going to take the other point, p of 8 equals $50.18. Again, t is 8, y is this, and we're going to plug in to this solution here. So we're going to let y be $50.18. Then we're going to have k, leave that alone, and then t is going to be 8. All right, you guys with me? Well, you got to know when I say proportional, that's xp. That's a product. And then you have to know that that's what we call a linear first-order differential equation, and its solution is given by the formula y equals c e to the kt. All right, so we got to solve this. All right, so what we do here is when you're solving this equation for k, you got to use logarithms. So we're going to divide both sides by 80. Okay, I'll take my calculator and I'm going to do 5018 divided by 80. And I'll just write down whatever decimals comes out here. So that's going to give 0.62725 is equal to e to the 8k. Right, now what I'm going to do is I'm going to take logarithm of both sides. All right, and remember we have this property of logs that says that comes down, so we'll end up having ln 0.62725 equals 8k times ln e. And let's see, then what we'll have is I'm just going to bring this down, so that gives us this. ln of e is 1, so we got 8k. Then I can divide both sides of this equation by 8, use my calculator to find what k is, and then I'll have this thing ready to put together. Okay, so if I take this and do this calculation here on my calculator, I'm going to get negative, you can verify that with me right now if you want to, 0.58. Okay, like that. All right, so I put that in. And then step 4 would be I just sort of put this all together. So I'm going to take this thing and write this as y equals 80 e to the k. K is negative 0.058 t. So that is the solution of that differential equation. So that is the price demand function. All right. So that's what you were looking for, is getting that price demand function. All right. Okay. So next problem, I'm going to see what we have on here, and we'll work this one out together to kind of finish this up here. Okay, so I'm ready for this last problem here. I realized my mic wasn't on, so I'm going to start over again with this problem right here. Okay, this is a different kind of situation. You have a differential equation with this structure. So those look the same way. Then this is the given solution. So this is a formula, kind of like on the last problem. In your book on page 743, it has 4 different types of differential equations and their solutions. I wanted to just do applications on this. You don't have to necessarily know these formulas. You can look these formulas up, so you don't have to memorize them. So anyway, what we have is, this is the structure. It follows that. So you've got the k m minus y. We have k 500 minus n. So the first thing we're going to do is we're going to pull out that formula. Second thing, we're going to take the point, the initial condition, and that's saying t is 0, n is 0, right? Okay, so what we'll end up having on this is we're going to take this solution right here. Now, the only difference on this end is this solution, instead of being y, that's going to be n, because this is dn over dt. That right there is going to be, that k follows there. This is a constant, so that's m. 1 minus e to the negative kt. All right, so that's how that goes. So what I'm going to do is I'm going to replace where I see a t, I'm going to put in 0, and where I see an n, I'm also going to put in 0, so I'm going to use that to find m. Okay, so I have 0 equals m times 1 minus e to the negative kt. Whoops, and let's see, t needs to be 0. So I'm going to put that in like that. And I'm going to solve this equation. So I'm going to get 0 equals m times 1 minus e to the 0. And see, that's 1, so we get 0 equals m times 1 minus 1, so that 0 is equal to m. Okay? Hold on, I got to pause here for a second. Got something going wrong. Oh, I made a little mistake here. I just caught this, and I apologize for this. In this equation, m is 500. Okay, so it's gonna kind of follow like that, see, so it's 500. So I wasn't paying attention, and I need to get that corrected. Now I probably got everybody confused, including myself. I apologize for that. Okay, so what we have on this basically is this. You have the structure of this differential equation like this, k m minus y, and then the solution that you would look up on page 753, and I had that right, that is y equals m 1 minus e to the negative kt, like that. Okay, well, we know that the m is 500, so we get y equals 500 1 minus e to the negative kt, like that. Okay, so that leaves us with trying to find what k is then. Okay, then once we do that. Okay, so I think I got my microphone and stuff working again here. So to finish up, okay, so again, we have this differential equation. This is the structure, right? And the solution is given by this. Now we know m. Now the only thing is, when you look this solution up, instead of having y, our variable is n, so our solution to this equation is n equals 500 1 minus e to the negative kt. And that leaves us with finding k. So step 3 is we're going to find k, because we got the m. Okay, we're not going to really have to use that. That ain't going to do any good, but this is. So we're going to find k by taking n of 10 equals 100. And again, that's t, and that's n. Okay, so what we're going to do is, where we see an n, okay, we're going to do these things. We're going to plug in 100 there. Where we see t, we're going to plug in 10 there. Okay. All right, so what I'm going to have then is, let's just work that out. So we'll have 100 equals 500 times 1 minus e to the negative 10k. Then we need to solve this equation for k. All right, so what I'm going to do, I'm going to divide both sides by 500. 1/5 equals 1 minus e to the negative 10k. Like, now I'm going to solve this equation. I'm going to rearrange. I'm going to move the e over here so it becomes positive. I'm going to move the 1/5 over here so it becomes 1 minus 1/5. That's one way to do it. To me, that's the easiest way to do that. And what I'll do from here then is we'll get a common denominator. That's e to the negative 10k is equal to 4/5 minus 1/5. Now I'm going to take a log of both sides. And I'm thinking ahead there. 1 is 5/5, not 4/5. Okay, like that. So that's going to give 4/5. Okay. And I got to do the log of both sides on this. So that side needs to be the log of 4/5, like that then. Okay. Right, bring down the negative 10, so we have negative 10k times ln of e is equal to ln of 4/5. That becomes 1, so we get negative 10k is equal to ln of 4/5. Divide both sides by negative 10, and you'll get k is equal to ln of 4/5 over negative 10. And then if you take your calculator on that and do that, you're going to get about 0.022. All right, so step 4 is we put it all together. Okay, so what I'm going to do here is this is the solution right here. We just need to replace that k. All right, so that's going to plug in right there. So the answer is, the final answer is going to be n of t is equal to 500 1 minus e to the negative 0.022t. That's it. Okay, that's how that goes. So these last two problems, you got to look up those solutions. It's on page 743 that's got solutions to common types of differential equations. Okay, sorry about the last problem. Kind of got off track there, not paying attention to the 500, but this is how you would get the solution of that problem. All right, so that will wrap us up. Hope this helps you to learn the section well.